All right, the irregular loop. So this time there are two different circles. There's the circle at the bottom of the loop, this guy, and then there's the one that forms the top up here. Okay, question 1 is identical to the one we did earlier, the standard loop, and I mean 100% totally identical. 1/2 mv initial squared, mgh initial, 1/2 kx initial squared equal to 1/2 mv final squared, mgh final, 1/2 kx final squared, plus E lost. There's no E lost, there's no spring. We're looking for the speed down here at the bottom of the hill. So there's no height there. There's a common m, so 1/2, you can cancel it out, 1/2 v squared plus ghi equals 1/2 vf squared. Vf squared equals vi squared plus 2gh, which is exactly the same, and the numbers are exactly the same as the other roller coaster we did. So hopefully you noticed that these are identical, and so I really do not need to be writing all of this out. You should get a VF of 40.86 meters per second. Okay, which will also be number 2, how fast is it going when it enters the loop? It's at the same height. This is really the bottom. I just didn't do a very good job when I was drawing. It's my line across. There we go. See, there it's the bottom. All right, number 3 wants to know, what is the centripetal acceleration applied by the track at the bottom of the loop? Same question as before, v squared over r, so 40.86 meters per second squared, and the r this time, if you can see it, is 50 meters. So 50 meters, and you should get an AC of 33.39, I think it is. 33.392 meters per second squared. Okay? Number 4, how many G's does the rider feel? So at the bottom of the loop, number of G's felt is equal to AC over G plus 1. So 33.392 meters per second squared divided by 9.81 meters per second squared plus 1. And this time you get the number of G's felt to be 4.40. So not nearly as bad as the 9.5 that would have killed you on the last one. Number 5, how fast is it traveling at the top of the loop? So just like before, like number 1 and then the last question, 1/2 mv initial squared, mgh initial, 1/2 kx initial squared is equal to 1/2 mv final squared, mgh final, 1/2 kx final squared plus E lost. Again, no E lost, no spring. We're looking at the top of the loop, so there's both a height and a speed. And if we use our original position, both a height and a speed. All terms have an m in it, so they go. You're looking for the speed, so bring this term over. So you'll have 1/2 v initial squared plus gh initial minus gh final equals 1/2 v final squared. Multiply everything by 2, so v final squared equals v initial squared plus 2 gh initial minus 2 gh final. So 10 meters per second squared plus 2 times 9.81 meters per second squared times 80 meters minus 2 times 9.81 meters per second squared, and the height is 40. This is identical to the last one. I didn't realize the height was 40, or I would have said that earlier. Add it up, take the square root, and you should get 29.74 again. Meters per second. Next question, what is the centripetal acceleration up there? So you do AC equals v squared over r. So 29.74 meters per second squared. And the R this time, though, is only 10 meters right here. Okay? So divide by 10 meters, and you should get a centripetal acceleration to be 88.47 meters per second squared. And now it wants to know what is the number of G's felt there. So AC is equal, sorry, we just did AC. Number of G's felt. Number G's felt is equal to AC divided by G, and we're at the top of the loop now, so minus 1. So 88.47 meters per second divided by 9.81 meters per second squared minus 1. And you should get 8.02 G. So right at the limit, but you might be able to survive it. And then number 8 wants to know how fast is it going over here. That is identical to number 8 in the regular loop. Exactly the same numbers, exactly the same everything. So I'm not going to do it because I think you should be able to. It's conservation of energy again. You can have the 4 terms. You're solving for the VF. The only thing that's different from what we have right here is that instead of 40, right there, you're going to put in 35. Okay, so that's the irregular loop. Today, I would like you to work on the roller coaster detective. But first, we have a few other questions to go over. We have 3 and 4 on the amusement park sheet. And they are both with the typhoon. So if you remember, the typhoon ride is a cylinder where you're standing with your back against the wall and the floor falls out. Fn is acting inward, Fg is acting downward, and friction is acting up. So in number 3 it says 100 kilogram man on a typhoon ride with a radius of 2.4 meters realizes he's moving at a speed of 6.3 meters per second. When the floor drops out, what force must friction provide to keep him from sliding? Well, you want to look at some of the forces in the y then to get friction. So some of the forces in the y equal to MAY, and if he's not sliding, this is 0. So acting up will be friction, acting down will be gravity. So friction needs to equal his weight. So 100 kilograms times 9.81 meters per second squared. Friction should be 981 newtons. That's part A. B says, what is the centripetal force? So, sum of the forces in the x direction will equal mv squared over r. So the centripetal force, which is really Fn, is equal to m, 100 kilograms, times v, 6.3 meters per second squared, over r, 2.4 meters. And when you do this, you should get a centripetal force, or an Fn, of, looking for my answers, of 1,653.75 newtons. That's my Fn. C says, what is the minimum coefficient of friction? Well, you have friction and you have Fn, so you should just be able to do FFR is equal to mu Fn. So mu is equal to friction over Fn. So 981 newtons over 1,653.75 newtons, and you should get a mu of 0.593. Then it says, should it be bigger or less than that? Well, I think you might want it to go bigger just because if he's going to slide, it would probably be good to have it a little bigger. Number 4 is also a typhoon ride, and we're going to run out of time on this one. Okay, person against the wall, Fg is acting down again, friction is acting up, normal force is acting in. And so it says, built with a radius of 3 meters, coefficient of friction is 0.5, assume a person of 60 kilograms is on the ride, what is the force needed to hold her up? In other words, what's friction?